Look at the sky. Clouds gathering, wind shifting, pressure dropping. For centuries, weather was guesswork, observation, experience, instinct. Today, it's computation. Weather forecasting begins with data. Satellites scan cloud movement, radar tracks storms, ocean buoys measure temperature and currents, ground stations record pressure and humidity. Every second, millions of data points are generated. Now, here's the challenge. Weather systems are chaotic. Small changes can create large outcomes. That's where machine learning enters. Machine learning doesn't replace physics-based models. It enhances them. Algorithms learn from historical weather patterns. They compare past conditions to current data. They detect subtle patterns humans might miss. This approach builds on foundational work in numerical weather prediction by scientists like Lewis Fry Richardson, who first attempted to calculate weather using mathematical equations. Today, machine learning accelerates and refines that vision. Now zoom in on disasters. Flood prediction models analyze rainfall intensity, soil saturation, and river levels. Wildfire systems track vegetation dryness, wind speed, and heat. Hurricane models evaluate ocean temperature and atmospheric pressure. Machine learning can predict flood zones hours or days earlier, detect wildfire ignition from satellite imagery, refine hurricane paths in real time. Minutes matter. Earlier warnings mean evacuations happen sooner. Infrastructure can be secured. Emergency response can mobilize faster. Now zoom out. Disaster prediction isn't just about safety. It affects insurance pricing, supply chain stability, agricultural planning, energy grid management, urban infrastructure design. If storms intensify, cities must redesign drainage. If droughts increase, agriculture must adapt. If wildfires spread faster, land management must change. That's why disaster modeling is integrated into global risk assessment. Organizations like the United Nations, through humanitarian coordination systems and environmental programs, use predictive modeling to prepare for extreme events and reduce vulnerability worldwide. Machine learning makes those predictions faster and more precise. But here's the critical point. AI doesn't prevent disasters. It reduces uncertainty. Nature will always generate extremes. The difference is preparedness. Before we end, zoom out one last time. Machine learning teaches a modern lesson. Prediction is power, but only if decisions follow. Environmental science now merges atmospheric physics, data science, and risk management because resilience depends on foresight. In the next episode, we'll explore AI for wildlife conservation and anti-poaching, where technology moves from predicting storms to protecting biodiversity. This series is part of the Learning Studio, where environmental science meets technology, policy, and real-world systems. This isn't about controlling nature. This is about preparing for it.